Firstly, it's a pleasure being here, meeting you all. I didn't know your background, or so maybe there are a few slides at the beginning that you already know, but I'll try to make it at least a little bit more interactive. So if it's known subject, we'll skip it. So that's the topic today. I would like to present a case study on the search and rescue, which would be one of the services provided by Galileo. And then I'll introduce you to this new feature in the end. But I will also talk on the current operational system. Okay, as I was telling you, well, the outline of the presentation, the basics on satellite applications, just really basics. We'll talk of benefits and cons and type of orbits that would drive you the type of application that you can run on your satellite. And then I will introduce you to COSPAS ARSAT and the future evolution of it, which is called MEOSAR, the Galileo application. So there are many benefits that can provide us the satellites. I will quickly enumerate some of them. We have the quick deployment, so we can quickly reach to cities, bridge to major infrastructures without civil works. So that's a quick deployment that allow us to be responsive. Obviously, the natural ability to broadcast and to reach wide areas, very easy. That's something that's natural for something that's above us. Cost effectiveness, having a satellite, the cost would be the same if it's just one user receiving the signal or many of us, such as TVs. So the cost is the same, so we can think a little bit that this can be beneficial. Obviously, due to the extensive testings and the quality of fabrication of the space technologies, those are quite reliable piece of technologies and flexible. So we can have one satellite with different payloads, providing different types of services. So that's some of the benefits that you can think. I don't know if you guys can give me one contra. Does anyone have an idea? So what is not beneficial of the satellite applications? No? Maybe they are expensive. maybe they're complicated to fix. No? Maybe they need also ground infrastructure. Some of them, they need to be, the orbit needs to be readjusted. And obviously, we have to think about also the delays and the limited bandwidth that we have. So, well, just to give you like a quick brief on that. Most of you, or maybe I've just been here in a few minutes, and yeah, I saw you just performing some simulations on orbit, so maybe you have it all in mind, but the mind driver of the satellite applications are obviously the orbit that you choose. We have mainly three kinds in grosso modo. LEO, MEO, and GEO, so that would come to that further down. And obviously, in order to choose your application, you need to think about what kind of orbit are you gonna use, and the orbit will be influenced by your mission. So, do we need high resolution? Do we need to see the same spot all day? Do we need to broadcast many data? So we have to think on the ground segment in order to gather all this data. So there are plenty of things that can drive your application, and the orbits, I think, is one of the most important one. So I just listed some of, like, from the 3 main orbits that you just saw. A quick, like, some of the main services that they provide. So in LEO orbit, we mainly use it for Earth observation and for internet and voice services due to they're close to Earth, so the delay is shorter, so it doesn't impact on the voice communication. LEO orbits are also used for search and rescue. MEO orbits, mainly the global navigation systems, and search and rescue. And GEO orbits, we have like obviously the TV, weather forecasting. We can think about many more. And search and rescue. So it is a quite used application, and it has something interesting. That's the main the brief introduction. So what I would really like to talk is how satellites are serving saving people in distress. So for this, I'd like to present you the COSPAR StarSat, or bear with me, I'll try it. Komischeska, Systemia, Poiska, Avarinic, Sudov, I don't know, was it close?
Not even close.
No, not even close. Well, that's Russian, I guess, for search and rescue satellite-aided tracking. That's COSPAR StarSat was founded in the late 80s by the US, the USSR at that time, France and Canada. Right now, it is an international organization approved or agreed by the UN, recognized by them, providing free search and rescue data. And nowadays, there's more than 43 participating countries, which 30 of them are providing ground infrastructure. Just some quick facts before cutting to the cheese. Since 1982, 30,000 people has been rescued. I'll do the math, so that's 1,060 per year. So 1,060 people per year has been rescued using this system. So for me, it's quite shocking. I was kind of surprised to get those numbers. Just in Europe last year, 100 registered distress events and 78 or 189, 78, where the COSPAR StarSat was helpful on rescuing the people in danger. Just to be also to talk about the first save. It was in early 80s, 1982, where a pilot crashed in a mountain area in Canada. The system was not even declared operational, but the agreement between the parties was already in place, and this little fella, COSPAS, was already in orbit. So you have here the timeline of the history, but basically this guy was lucky to have on board a distress beacon. He activated after the crash, and on the next day, because the orbit was kind of slow, on the next day the satellite picked up the distress signal, and the Canadian authorities could find it in 10 miles from where the satellite was precisely pinpointing its position, and the guy was saved. An overview on the whole system. The system is working in these five mission stages. So firstly, the people in distress activates a beacon. It can be a personal beacon, beacon on board a plane or a boat, This signal is picked up by the satellites, which relay the data to a ground station called LUT, as per local user terminal. The LUT, the ground station, forwards the message after it has been processed to a mission control center, where they validate and check the data. And after that, they coordinate with the local rescue center, which actually launch the search and rescue mission. So we'll go a little bit on a zoom on all those 5 stages. There are roughly nowadays 1.5 million registered beacons. We have here like the percentage. Most of them are maritime. Some of them are what you call personal. So it's a shame that I forgot it. But anyway, it's like a phone. It's not very big, so you can carry it with you, and it might save your life. And like the rest is for aviation. They have many differences. For example, the aviation beacons activate if G-forces are, I don't know, I don't have in mind the specs, but overpassing the normal values, so they automatically activate it. And for example, maritime, when they reach the contact with the water, they automatically activates. So in case that you cannot reach the beacon, it activates itself. Here you have, like, nowadays beacons work at this frequency, and the signal is digital, obviously, and they broadcast it's just 36 hexadecimal bytes, which identifies your beacon, the country of the region, and then the newer models, even they have an encoded GPS position that obviously helps in terms of locating the beacon, but that's not always the case, and sometimes the beacon has not enough time to get the lock, so the position is not truly where you are. In terms of space segment, we have currently 5 LEO satellites and 8 GEO satellites. Those are the initial ones, and there are now some more. The LEO ones, which are listed here with their footprint, so roughly 3,000 kilometers, so the size of Australia. They orbit pass, it's 101 minutes, 6 times per day. And they have an onboard processor, which is charged to get the signal and make all the processing. And then it has also an onboard memory, and it crashes all the processed data as soon as it's available. In average, you need roughly 2 hours to get a localization from an activated beacon due to the Doppler effect technique. So when the satellite goes on, we'll see it later maybe, but get the idea, roughly 2 hours if you're lucky and the satellite is in view. In terms of the GEO satellites, they have obviously a larger footprint, but they are not able to locate the beacon. They can just provide more data for localization process, so they only detect the signals. But obviously they have global coverage, and they have instantaneous localization.